So again, I'm Roger Grimes. I've been doing computer security 34 years. I've written 13 books and over 1,100 magazine articles on computer security. Most importantly, I wrote a book called Hacking Multi-Factor Authentication, which discusses the many ways that anybody can hack different forms of multi-factor authentication. I and many thousands of others can hack any MFA solution. There is no such thing as an unhackable anything, much less an unhackable MFA solution. And many of them can be hacked, 5 to 10 ways. It's not a rarity. I work for KnowBe4, we're the world's largest integrated security awareness and simulated phishing platform vendor. We just try to help people not to get phished. Let me keep on going here. Although I'm going to show today, I don't have time to show you 50 ways to hack MFA. I'm going to try to show you at least 4 ways. But I like to tell people is that MFA is a good thing. You should use MFA where you can to protect sensitive and valuable data. And so MFA is a good thing, but it just isn't unhackable. And a lot of people are surprised by how easy it can be hacked. And sometimes simply being sent a phishing email. The first one I'm going to show you, and Kevin Mitnick, our chief hacking officer, who his zero-day exploit thing was actually referenced in the last talk. He's going to show probably one of the most common ways to bypass or get around MFA, and it probably works on 85 to 90% of MFA solutions. This particular one's called it's kind of a man-in-the-middle attack, and what it does is it really doesn't care how you log in, whether you log in with a name and password or whether you log in with a multi-factor authentication solution. They just wait till you successfully log in, and then they man-in-the-middle attack, or they've set up a man-in-the-middle attack, which means they have some type of machine or proxy or website in between the potential victim and the website they think they're going to, and then they can capture all the communication sent from the client to the server and from the server to the client. And in most cases, most website logins are represented by a text-based cookie. And the man-in-the-middle attack that Kevin's going to show you is where the person logs on. He's going to be both the victim and the hacker, but he's going to log on in and steal that text-based cookie, take it over, and steal that person's session. It's one of the most common ways to bypass MFA. It's been used to bypass MFA to the millions and has been used for decades. The first time I first saw this and wrote about it was 1997, so it's been around for quite a while. In this particular case, Kevin, again, is the hacker and the victim. He's going to convince his victim to visit a rogue lookalike website. So actually, he's going to send them to a fake domain that then proxies all the real website to the client, and then everything the client types in or does, login name, password, MFA code, or whatever, the hacker can pick up, but they also retransmit it to the real server, and then eventually the real server, after the victim successfully authenticates, sends back that text-based cookie. The man-in-the-middle attack capture is going to capture that cookie and then replay it on the machine to take over that session. This is a very common attack. Again, it works against 85–90% of MFA solutions. And if you want to see this attack or read more about it, I've got a link in this slide deck that you can download. But let's go ahead and I'll show you the solution right now, or show you the video.
This is the attacker system in the cloud, in the Amazon cloud in Virginia. And we have logged into Outlook 365. So here, I'm simply just going to click on the email. I just click. It takes a second for Office 365 to load. And here we go. We could see that the email's from Roger Grimes at nsa.gov, which is quite interesting. And there's nothing there. There's no hyperlink to click on. There's no attachment. But if we go over to the attacker system over here in the cloud, we were able to intercept or obtain the victim's NTLM v2 hash. So let's go ahead and try to do this. So we're going to go ahead and highlight this. We're going to copy it. We're going to go over to our password cracker over here. We're going to create a file. Here we go. We're going to paste in the hash. Very simple. And then what I'm going to do is just run a shell script that tries to crack the hash through a dictionary attack. And this is using a tool called Local Hashcat. And guess what? It's already cracked the hash. So if we scroll up here, we see it was a user named Kevin, right? And
Actually, I've got the wrong video there.
This is the attacker system
This is
in the cloud, in the Amazon cloud in Virginia. And we have, I'm logged into Outlook 365 here. I'm simply just going to click on the email. I just click.
This is the wrong video.
This is the attacker.
Let me see if I can get rid of this video here and get the right one. Stand by. I apologize for that. I put the wrong video got here. So stand by. I'm going to insert the standby for just 1 second. Boy, I can't believe I got the wrong video there.
Roger's got so many clients contacting him around the world, and this stuff does happen, but the premise, what we wanted to showcase here, exactly how relatively easy it is to get hacked, and what are the practical recommendations that Roger and his team can share with you.
Yeah, here, I'll get it right here. And again, I apologize for having the wrong video. I've got so many Kevin Mitnick hacking videos that somehow I had the wrong one. But let's try this again. And let me know if this doesn't show up, but it should. Let me do.
Hey, Roger, can you just to put some context and make sure there's no confusion, can you just briefly describe what this hack is again so people know exactly what you're showcasing?
Yeah, it's going to be an MFA hack where Kevin's going to be both the victim and the hacker. And when he's going to open up a phishing email, he's going to think he's going to LinkedIn, but really he's going to be going to this man-in-the-middle proxy website. He's going to put in his MFA credentials. The hacker is going to steal those credentials and the resulting cookie that's sent from the website saying that he logged in successfully, so that he, as the attacker, can log in as that person. So again, let me know if you're not seeing this video.
Kevin Mitnick, KnowBe4.
I can see it, and based on your description, I'm already a little scared.
And if you take a look in the second email here, I'll go ahead and open it. It appears to be an email from LinkedIn. And ordinarily, when somebody wants to join your network on LinkedIn, LinkedIn will actually send an email to your email address notifying you of that. And if you're interested, you can go ahead and click interested, log into your LinkedIn account, and authorize that person to actually become a connection. So if we take a look here, we have an email from LinkedIn that says, Kevin, I've read about your adventures in Ghost in the Wires and so on, and this person wants to join my network. But this is actually a phishing attack. If we take a look here at where the email is originating from, it's not at linkedin.com, it's at this domain called llnked.com, which people might overlook. So let's go ahead and pretend that we're the victim here and go ahead and click on interested. And what that is going to do, it's going to redirect us to the LinkedIn website to go ahead and log in. But let's move this over to the right and let that load. And if you take a look over here, we have a blank white page, which is going to become very important in a moment. And this is the attacker terminal session. So let's go ahead and bring back the virtual machine that's now connected to LinkedIn to authenticate, because we, again, clicked on interested in the email. So we'll go ahead and put in a username, Johnny Boy, at mitnicksecurity.com. And now we're going to go ahead and put in our secret password. And we're going to go ahead and click sign in. And when we click sign in, it's not going to allow us to log in. What LinkedIn is going to do is request our two-factor authentication code that LinkedIn is going to actually send to my mobile phone. And in a moment, you should hear a sound that the text message was received on my mobile phone. So let's go ahead and click sign in. And here we go. It's telling us that two-step authentication is enabled. We just heard a message come into my mobile device. We're going to uncheck this box that says recognize this device in the future. And I'm going to open my mobile device to take a look and see what the text message is, or what the code is rather. So the code here is 421476. We're going to go ahead and click verify. And when we do so, it's going to log us into my LinkedIn account. So now we're logged into the LinkedIn account, but let's take a look at the attacker session over here on the left. So we're going to scoot this over to the right. And over here, what we have is what we're able to intercept. So we're able to intercept the email address, which is johnnyboy@mitnicksecurity.com. We're also able to intercept the password to the account, which is KnowBe4 rocks. And over here, this is not the actual 6-digit code that was intercepted, because you can't really use the 6-digit code again, the second factor. But what we're able to do is intercept the session cookie. And if you're able to steal the session cookie, or if rather the attacker is able to do so, they don't even need your username or password or second factor code. They could simply load the session key into a browser and they actually become you. So let me show you how this works. We're going to highlight the cookie. We're going to copy it to the clipboard, and then we're simply going to open up Chrome in incognito mode. And incognito mode just means with privacy. So now we're going to go to the real LinkedIn website. We're going to go here. Obviously, we're not authenticated. Now it's, wants us to log in with our credentials, but we don't have to do so. We're going to go ahead and go into developer tools. We're going to go into the console, and what we're going to paste into the console is the session cookie that we stole from the victim, which was myself, by the way. I'm going to enter it. I'm going to go ahead and close the session. Now, all I simply have to do to be logged into the victim's account with their session cookie is simply hit refresh now. So I hit refresh, and here we are. We're logged in, or rather hacked my own account.
So sorry about that, and I'm going to kind of speed up a little bit. But again, what Kevin did is, trick the victim in going to a fake website, just a simple phishing email. It was a proxy site, and it just sent everything between the client and the server to the client. The hacker was able to get the login name, password, but also the resulting cookie. And this, he used something called Evil Jinx, but there's literally a tool called Evil Jinx. There's literally dozens and dozens, if not hundreds, of programs that can do the same thing. It's been done for many, many years. It's used in many real-world attacks. Like here is somebody was claiming that he went to a fake Binance website. That's kind of like Coinbase, where you go to buy and sell and trade cryptocurrency. So the fake Binance site stole his login credentials. He was using Google Authenticator, and it said then during the 60-second timeout for him putting in the credentials, the fake website stole it and used it on the real website. So this is really, really common. It happens all the time. Here's another example where Iranian phishers bypass 2FA protections offered by Yahoo Mail and Gmail. And it says again, if by chance the people had 2FA enabled, the attackers would redirect targets to a new web page that requested the one-time password. They'd capture that one-time password or steal the cookie and then log in as them. This works against any MFA solution that doesn't require that the website be registered on the device and the device to the website. Like FIDO2 devices require that registration, but most MFA solutions don't, and so they can be man-on-middle attacked with a very simple phishing email. Another new type of attack is just know that if your endpoint gets compromised, it's game over, right? If your machine gets owned by a virus or a Trojan, they can do anything that you could do, including they can start a second hidden browser session. So there's a really common type of Trojan out there called banking Trojans or Bancos Trojans, because it started in South America and actually in Brazil first. But essentially, they wait for you to log on to your bank. So you get compromised by this Trojan, you log into your bank website, and then it starts a second hidden browser session and transfers all your money to some other bank. You don't even know it's there. Your bank doesn't know that it's not you because it's coming from your PC. You just successfully logged in, possibly using MFA, and all your money's gone. You think that you're just looking at your bank balance or something like that, and the next thing you know, all your money is gone. These are very, very common. These have been used millions and millions of times to steal probably $1 billion. Like here's an example of one Bancos Trojan. It was 10 guys, 11 members of the Gaznim malware network stole $100 million from 41,000 victims with the help of a stealthy banking Trojan. Again, there's literally hundreds and hundreds of these Bancos banking Trojan gangs out there all the time. They stole billions of dollars. Here's another example where if you got tricked into downloading these Android battery optimization app, it really was a banking Trojan, and it waited for you to log into PayPal. I don't have time to show you the video, but if you logged into PayPal, it would then transfer as much money as it could using your PayPal account to their account. And just if you download these slides later on and take a look at that video, very interesting to see. But these bank stealing Trojans are very popular today, especially on mobile phones. Like one of the biggest mobile phone Trojans today is called EventBot. And it says EventBot targets users of over 200 different financial applications: PayPal, Barclays, Capital One, HSBC, and so on, and Coinbase, and so on. These are very, very popular. And if you get tricked to installing a Trojan, many times they're going to be able to steal your money once you have successfully authenticated to your bank website. The third type of attack I'm going to show you is what's called a SIM swapping attack that has to do with SMS-based MFA. The most popular form of MFA on the internet is SMS-based. We're all used to getting these little codes that get sent to us on our mobile phone messaging app that says, here, put this code into the web browser, that sort of stuff. But what hackers learned a long time ago is that they could do what's called a SIM swap attack. And SIM stands for Subscriber Identity Module. Essentially, it's some information that identifies your phone as your phone to your phone number. But they could many times trick the telephone company into transferring your SIM information to their new phone, their burner phone. So they call and they claim to be you. They've usually phished you and gotten some basic information from you. Then they use it at your cell phone company and go, oh, I've got a new phone. Can you transfer my SIM information to this new phone? The cell phone company does, not knowing that it's not you. Your cell phone just stops working for a while. And most people don't even know that it's occurred for an hour or longer, because it doesn't tell you that your SIM information has been swapped. It's just that your old phone stops receiving maybe emails or messages and can't make calls. Usually takes the person a day or two to get their cell phone working again. They call the cell phone company, go, hey, my cell phone's broken, it's not connecting. The person's like, oh, I transferred it to your new phone. That's what the history shows. You're like, I don't have a new phone. No, but the attackers did. And then they go into your accounts, your bank accounts, your stock accounts, and go, hey, I need to have an account recovery, and the account recovery sends that login code to them. They then use that to log in and steal your money. These SIM swapping attacks have been used to steal millions and millions of dollars every year, all the time. Even Reddit used SMS-based MFA to protect the network. An attacker, compromised their SMS-based authentication and then compromised the Reddit servers, and even I think tried to implant a backdoor Trojan on there and got some customer information. And just know that if you're not an Uber hacker and you don't know how to socially engineer people out of their cell phone information, for $16 you can actually send a fake letter of authorization to many of these companies around the world that allow you to just literally get somebody's cell phone SIM information sent to you. You just have to make up a fake letter, pay $16, and there's all these companies around the world that will reroute somebody else's SMS messages to your phone. So for $16, you can go steal something out of somebody's bank account. And this last attack here, just know that SMS, it's really easy for anybody using SMS to fake being anybody else. Like if I know that you have a Gmail account and I know your phone number, I can send you a message claiming to be from Google. I can say, hey, I'm from Google Security. We've detected a rogue sign-in to your account. We're not sure who is who. And so we're going to send you a verification code, and we need you to tell us what that code is. The victim's like, oh, okay, they're going to be sent a code. I'm used to getting codes. Then the attacker goes to the person's Gmail account, so tries to log in as them, tells Gmail that the hacker says, oh, I forgot my password. Google goes, oh, let's go to account recovery, gives you 4 different ways to recover. One of the ways they allow you to recover is an SMS-based code. That code gets sent to the victim. The victim types in that code to that first security message, and boom, the account is owned. So it's that simple. And the problem there is you can't trust who that person is. How do you know it is or isn't from Google Security or Microsoft Security? This type of rogue recovery type thing is done probably thousands of times a day. Happens all the time. I've kind of it's real life here. I apologize for running out of time for messing up that demo, but now if anyone has any quick questions, we can take them. But thank you so much for putting up with me and my mistakes today. And you can always email me at rogerg@knowbe4.com, and I'd be glad to send you this and other hacking MFA demos and information.
Hey, Roger, Ron Gerber here. We've got about a minute left. What should people do differently to ensure that they don't fall victim to these MFA hacks?
Yeah, what I try to tell people is just realize that that all MFA solutions can be hacked. Learn what are the different types of hacks that could be successful against each type of solution, and just educate yourself and anybody in your company that uses that same type of MFA solution about those sort of attacks, so that you're less likely to be tricked by them. Like most people that are using MFA probably think that they don't have to worry about phishing as much, but 90% of MFA solutions, a simple phishing attack gets around them just like they're not even there. So just be aware of the different types of attacks, so that education's a good thing.